Let's go through another example similar to the one that we just did. This is the angle side angle situation, and in this case, again, I want to solve for some missing sides if I'm given these angles, and we'll find that it's kind of like our last situation with the angle side, only slightly different. So let's go through an example right here. Let's say that we're told angle A is 21.5 degrees, angle B is 105.2 degrees, and side C is 57.4 inches. That is, we're given this information right now. We know that angle A is 21.5 degrees. We're told that angle B is 105.2 degrees. I know that the drawing doesn't look it, but it's immaterial to our discussion. And that side C is 57.4 inches. If we're given units, we do need to be careful to make sure that we employ the correct units when we're finding our answer. So we will have to be able to use our law of sines to make this work. Now, as it stands, we don't have enough information. And the reason is that in order to use the law of sines, you must have at least one side and an angle opposite of that side to set up the correct ratio. All right. Well, because we don't have that information, that means that we definitely have to start with solving for our missing angle right here, C. But luckily, that's not a hard thing to do. And the reason is, of course, that all the angles must add up to 180 degrees. Therefore, angle C will be equal to 180 degrees minus 105.2 degrees minus 21.5 degrees. That gives us angle C of being 53.3 degrees when I work that out. Again, anytime I'm getting an answer here on the screen, verify that with your own calculator. All right, so we found side C. So now we're really just bound by finding whatever missing sides we want. So let's go in alphabetical order this time. We're going to find side A, and we're going to find side B after that. So let's just run through the numbers. Side A, the length of side A, would be divided by the sine of its opposite angle, so the sine of 21.5 degrees, will be equal to, and we'll go with our given side of 57.4 inches divided by the opposite angle we just found, sine of 53.3 degrees. So finding A is just as easy as taking 57.4, multiplying that by the sine of 21.5 degrees, and dividing that by the sine of 53.3 degrees. And when we work that out, I used my calculator and I found 26.24 inches would be the length of side A. Doing the same thing for side B, we would find that B divided by the sine of its opposite side. So the sine of its opposite angle, 105.2 degrees, would be equal to the length of side C. Again, we're going to go with 57.4 inches divided by the sine of its opposite angle, which is 53.3 degrees. And working that out, B will be equal to 57.4 times the sine of 105.2 degrees divided by the sine of the C, which is sine of 53.3 degrees. And I come up with side B is equal to 69.5 0.09 inches. And again, we should check that situation by using a little table right here. So I'm going to put my side and my angle side by side so I can compare and see what works. If I do that, well, side A we found to be 26.24 inches, and angle A was 21.5 degrees. We found that side B was 69.09 inches, and that angle B was 105.2 degrees, and that side C 57.4 inches, in which we were given, and its opposite angle was found to be 53.3 degrees. And so, does it make sense? Well, the shortest side appears to be opposite the shortest angle. The longest side appears to be opposite the largest angle, and therefore, everything's copacetic. All right, a little bit more explanation and example to come. Stand by.